A very good afternoon, a very good morning, everyone, and welcome to today's webinar. My name is Abhilash, and I am from the AD Solutions team here at Manage Engine, and I would be your speaker for today. Now, before we get started, I'd like to thank you all for joining in. Thank you so much for being a part of today's webinar. For those of you who already know me, thank you so much for joining in again. And for those of you who are new here today, welcome aboard. Now, before we get started, I would like to run a quick audio video check because I want to make sure that everybody out here today is able to hear and see the screen well. So a quick video check first. If you can see the screen well, all right, if you can see the title, that's Password Security in the Age of Hybrid IT Systems, my name and my email ID, just say yes via the chat box. Just punch in yes, just say okay via the chat box, so I can confirm that you can see the screen well and clear. I repeat, if you can see the screen well and clear, just punch in yes via the chat box, please. And if you can hear my voice, if the audio is well and audible without any distortion, please punch in yes via the chat box. All right, thank you so much. So yes, today's webinar is about password security in the age of hybrid IT systems. All right. Now, the reason I chose this topic is because passwords, they are the first line of defense for any organization. The first thing an attacker will try and do is to break the user's password. All right. And over the years, we have probably heard system administrators, we have heard cybersecurity experts often stress and talk about password security, how to create strong passwords, tips and tricks that we may have come across to create strong passwords. All right, but why is this still the case? The Verizon Data Breach Investigations Report 2019, the latest report that just came out, states that 80% breaches are still tied to user passwords. Right now, Active Directory was introduced in the year 2000. This is 2019, but why are passwords still a problem? The issue here is not with passwords, is with the password policies. Now, we are trying to create strong user passwords from what is a very old password policy. Right, so we are trying to solve the problem on a superficial level. We aren't getting to the root of the problem. Now, before I jump into the agenda, I'd like to tell you that all the source links are embedded within the slides themselves, and the slide deck would be emailed to you post the webinar. So if you have any questions, please keep them coming in via chat, and I would happily take them as soon as the webinar ends. Or you could always reach out to me on my email ID at abhi@manageengine.com, and I would be more than happy to help you out. All right, so let's jump into today's agenda. I will be talking about Active Directory's password policy. Now, I said that the password policy is weak, right? Let's see why exactly is it weak. And in the second part of today's webinar, I will show you a live remote brute force attack. That's right. I would be performing a brute force attack from a member server on a domain controller. Now, this is just to prove my earlier point where I said that Active Directory's password policy is weak. All right, and then we will employ a step-by-step approach where first we will find users with weak and vulnerable passwords, and then we will employ a different strategy, a strategy wherein we will implement stronger password policies, not just across Active Directory, but across the hybrid Active Directory environment, right? Because like I said before, stronger policies give stronger passwords. And just having username and passwords in today's cyber attack scenario is not sufficient. All right, so what we need is an additional layer of security. So in the fifth part of today's webinar, we will learn how to implement another layer of security with two-factor authentication. And finally, we will learn to implement single sign-on techniques. Now, the reason we are implementing single sign-on is because we have all the while been building on security, right? We found the weak user passwords, we have stronger policies, we have two-factor authentication, but the end user's experience is not smooth. And if the end user's experience is not smooth, that could lead to further breaches. All right, so let's go ahead and jump in. This is Active Directory's password policy. If we get into computer configuration all the way to account policies and password policies, this is what we get. These 6 settings determine the strength of passwords in the organization. All right, these 6 settings are what are used to create passwords in an organization. They look pretty robust, right? Take a look at this. The password policy was first introduced in the year 2000, right? With Windows Server 2000, these 6 settings came into the picture where they were used to create passwords in an organization. All right, and from Windows Server 2000 to 2003, these 6 settings were used, and the catch here is that password policies can only be applied directly on the domain node. They cannot be applied on the OU level, and they cannot be applied to a group or an individual user. Now, Microsoft heard our problems and they came up with something called fine-grained password policies, or password settings object to be more precise. Now, these policies can be applied to groups or users, but the catch here is that they still house the same 6 settings. And all the way to Windows Server 2012, all we got was a GUI for fine-grained password policies. So from Windows Server 2000 to 2019, we are still using these 6 settings to create passwords. Now, I can go on and on about the problems about password policies, but the point I'm trying to get here is when we have such legacy systems in place, we are bound to be breached, right? Especially in today's hybrid Active Directory environment, where a user has to log on multiple times, hence uses multiple passwords. If the first layer of defense of our organization is not strong, we are bound to be breached. Now, you would have heard of Azure AD password protection, right? This is Microsoft's latest attempt to ban weak user passwords and strengthen user passwords. Here are a few limitations that come with it. The first is that the Azure AD password protection uses an undisclosed global list of 1,000 banned passwords. Right now, these are 1,000 banned passwords that nobody has heard of and are subject to change anytime. Now, custom passwords can be banned using Azure AD password protection as well, but they cap at 1,000 password limit. Now, if we wish to set more passwords to be banned in an organization, we can't do it. And the age-old problem comes into the picture again, where Azure AD password protection cannot be applied directly to an OU, right? So it's just one size fits all. When you turn on Azure AD password protection, it applies to all of your users, even your privileged, your sensitive users, and your standard users as well. And the most fundamental issue here is if you don't have Azure AD, you cannot use it. If you do not use applications that probably have Azure AD as the backend, for example, Office 365, you cannot use Azure AD's password protection. Azure AD's password protection is not a real-time engine. It refreshes password policies only once every hour, and all the DCs must be updated to Windows Server 2012 for Azure AD password protection to work. Azure AD's password protection needs a premium P1 or P2 license or an enterprise license, which costs about $6 a month, and a reboot of a DC is required whenever the agent is installed or whenever the agent is updated. And Azure AD's password protection works on the basis of password points. All right, so this is how it works. Now, every banned password, every banned word is given a point, and every unique word is given another point. All right, so check this out: contoso blank 1 2. Right, so that's 1 point, 2 unique characters, so that's 2 points for those. And if the final result is less than 5, it means the password is rejected. All right, and if the final result is equal to 5, it means the password is accepted. But take a look at this password. It's the same password, but all I did was to add an exclamation mark. Right, so that's 1 point, 1 point, 3 points, and password accepted, although I am using banned words in the password. All right, so this is how weak Microsoft's password policies are, and Azure AD password protection is Microsoft's latest attempt. Alright, and the important thing to keep in mind here is this algorithm that I'm talking about is subject to change anytime according to Azure's security research and analysis. Alright, so now time for the live brute force attack. Now I would be performing the attack as a domain user, right? So a domain user with absolutely no privileges will be performing the attack on a domain controller on the administrator's account. Alright, so let me quickly head into my DC here. So this is my VM, sorry, and let me quickly show you something, right? If I open up PowerShell, you can see that I am logged in as a user called James, and if I punch in net user James, this is what we get, right? So James is just a member of the remote desktop users and the domain users group. James is not a member of any privileged group whatsoever. Alright, so this is just a regular domain user logging on to his domain join system. Alright, now with that established, let me quickly show you something else. Now I will need to run a command called nltest/dclist and then the name of the domain. Alright, now the reason I'm running this command is because in order to perform the brute force attack on the domain controller, we need to know the name of the domain controller. Right, and it's not a normal scenario where users of an organization generally know the names of the domain controllers. Right, so once I hit enter, this is what we get. Right, so this is the name of the domain controller right here that we will be performing the brute force attack on. Alright, now that we have the name of the domain controller, let me show you something else. If I open up command prompt right here, right, so here we have a command prompt. Now all I have to do is run a command called wmic user account get name comma sid, and once I enter, we can see that Active Directory pushes out all users in the organization along with their respective SIDs. Alright, now keep looking, and once we find 500, that is the SID of the administrator. I repeat, any SID that ends with 500 is the default built-in administrator of the organization. Right? And in this case, the name of the administrator is Brad. Now this is a smart attempt by the administrator because he has tried to change the administrator's name to something else. So uninformed attackers cannot guess that Brad would be the administrator. But in this case, we knew that the SID was 500. So we knew that Brad was indeed the administrator. All right, now that we know the administrator and the DC's name, let me quickly show you something. This is the script that I would be using to perform the brute force attack. So this is the name of the user. This is the name of the DC that we found by running the nltest command. And this is the password file that we would be using to perform the brute force attack. All right, so let me quickly take you to see users in public. So that's localdisk C, users, public, and these are my passwords that I would be using to perform a brute force attack. All right, so with that sorted, let me quickly show you how this is done. If I right click on the script, properties, security, let me quickly copy the path right here, and let me open up PowerShell now. And now I will run a command called PowerShell.exe-exec and then bypass. And once I enter, it's done. And the reason I'm running this is because Microsoft does not let you run scripts that are not digitally authorized, right? That are not digitally signed, from Microsoft. So in order to run any malicious script, this command is a must, and keep in mind that this command can be run by any user, right? So once that's done, let me go ahead and paste the path of the script. And once I enter, check this out. We can see that the brute force has started, and within seconds, we have the administrator's password, right? And we try to brute force 42 passwords right here. Right now, this is just a small list. This is just a list of 100 passwords, but you could potentially brute force 1,000,000 passwords or even more than that. It just depends on the length of your password text file. All right. So this is how the attack panned out. We started off as a non-privileged user, right? A user with absolutely no privileges. Then the user performs reconnaissance a step-by-step approach where the user finds out the names of the DCs. And then the user finds out other usernames along with their SIDs, hence determining that Brad is the administrator with SID 500. Alright, then the user uses PowerShell again, a built-in Microsoft tool, to perform a brute force attack of passwords. And immediately within 10 to 20 seconds, we have access to the administrator's account. The important thing to keep in mind here is this attack was performed by a user with no privileges whatsoever. An insider gone rogue. An attacker with access to an insider system can perform this attack. Alright, so why did I choose the administrator's account to perform the brute force attack? Reasons is because the administrator's account SID is always 500, right? Whether in the SAM database or in AD, the SID is always 500 and is never subject to change. All right? And the admin has powerful and widespread access. This is not news. All of us know this already. The admin's account has powerful access over the domain and over the local system. The admin account can never be deleted and can never be removed from the administrator's group. Admin accounts generally use shared passwords, right? For instance, admin account's password 123 at one system, is generally reused across multiple systems, right? So a brute force attack on one system can be replayed across the other systems, all right? And the most important thing here is admin accounts have no lockout policy. This makes them the most favorable target for attackers. Now, if you can recollect the attack, we tried 42 passwords, right? So if there was a lockout threshold set, then the admin account would get locked. But this never happened because the admin account has no lockout policy. All right, so a few tips that we could employ to secure our admin account from brute force attacks. The first thing I would say is disable the admin account and create another account with a different SID. Change the name of the admin account like we did, change the text in the description. But then again, attackers can do a reverse lookup using SID 500. But this is often a useful step when the attacker is not informed. All right, create a honeypot admin account. This is a decoy admin account with limited access powers, and then audit for activity. If there is a brute force attempt against the honeypot admin account, then that is probably an attack attempt on your organization. Use complex and random passwords. Use unique passwords across each system and ensure that passwords for the admin account or for any account for that matter are not repeated across systems. All right. Restrict anonymous access and restrict enumeration of SIDs. Whenever users run commands to enumerate SIDs or SAM account names, make sure you track those commands, and there are settings in the GPO such as this. All right. Now this setting is in the security options all the way in the local policies of the computer configuration. And what this setting does is it basically gives your anonymous users. Your anonymous users are users who do not need passwords to log in. All right. So it gives your anonymous users the right to query for user name SIDs and to query the SAM account names for users as well. All right. So that would be our next step. Restrict complex anonymous access and enumeration of SIDs. All right. So we need a step-by-step approach to combat password attacks and password problems such as this. So the first step is to find the weak user passwords. All right. The second step is to strengthen the passwords with stronger policies, and not just across native AD, but across hybrid AD. All right, so we need stronger passwords everywhere. And finally, two-factor authentication plus strong passwords gives us the security, the control that we need. All right, so let's jump into step one, find the weak user passwords, because awareness is the first step to security. We need to know which of our users have weak user passwords. All right, so these steps must be performed in order to run a password strength in Active Directory. You need to import the DS internals module. In this way, PowerShell will be able to talk with Active Directory. Once that's done, you need a list of weak used passwords in a file. Now we can help you with the weak set of passwords as well. And then you need to take the passwords in that file and convert them into NP hashes. And then you need to get the hashes from Active Directory and compare both the hashes, and if they match, then you have a weak user passwords. Alright, so this is how you can use PowerShell to find out weak passwords in your organization. I'll just stop this here by saying that it is not a one-step process and you will need to do a lot of scripting. Right, it's pretty evident. Now we have a free weak password reporter tool that can be used to find out weak passwords in an organization. So let me quickly show you how that works. This is the weak password reporter tool. Alright, so all you have to do, given the domain name, the name of the domain controller and the administrator's name and the password, and within seconds you will have list of users with weak user passwords. Now how does it decide what the weak passwords are? It does have a password patterns.txt file over which there are about a lakh of weak user passwords where you can add in your own sets of passwords as well. Alright, so using the weak password users report, we can determine which of our users have weak user passwords. Alright, so that is step 1. And step 2 is stronger password policies, because like I said before, stronger policies give stronger passwords. Alright, and in such cases, AD Self-Service Plus can be of help. So a quick recap on what AD Self-Service Plus is. It is a self-service password management and a single sign-on solution. So it basically helps your domain users to perform self-service activities such as resetting their own password, unlocking their own account, or updating their personal data such as email or their phone numbers. It helps your domain users with single sign-on techniques. So that's one-click access to all custom cloud applications. Administrators can leverage AD Self-Service Plus to enforce stronger policies, not just across native, but across hybrid AD, and set up two-factor authentication that's for both local and remote logons, and securely sync passwords across cloud applications in a hybrid environment for all-round security. All right, now this might be too much data. Let's go ahead and see this in a step-by-step process. So how is AD Self-Service Plus's policies better than the native password policies? For starters, AD Self-Service Plus provides role-based password policies. All right, so these password policies can be applied based on OUs, on groups. So that's different levels of password strictness based on the sensitivity or the privilege of your users. For example, your domain admins require stronger policies, whereas your standard users, not so much, right? And then it has modern password policy settings such as blacklisting of words, predictable patterns, and password checking, password reusability. All right, these are settings that are in accordance with today's cybersecurity requirements. And the password policy works across native AD. So when admin perform a reset across the ADUC tool, or a user performs a change password via the GNACP screen or the Mac login screen, the password policy can be enforced. It's completely customizable, so you can set the password policy according to your organization security requirements, and it does support multiple languages. Now I would encourage that you take a look at this link so you can compare password policies across native, across Azure, and across AD Self-Service Plus. All right, so let's go ahead and enforce stronger policies with AD Self-Service Plus. So if I head into my browser right here, let me log in to AD Self-Service Plus. If I head into configuration, you can see that I am logged in as the admin. And under policy configuration, this is where AD Self-Service Plus policies are set up. All right, so if I quickly click edit, we can see that policies in AD Self-Service Plus can be applied based on OUs, on groups, and on individual users. All right, once a policy is created, all we have to do is head into Password Policy Enforcer under Self-Service, and this is where the password policy can be enforced. Right? Take a look at these settings. These are settings that we need to prevent such attacks. For example, the minimum password length for the organization, a maximum password length, number of special characters to include, ban the use of characters from an older username or an older password, ban the use of dictionary words such as this, right? Because this can help prevent dictionary-based attacks, and ban the use of patterns such as this. Now let me quickly show you a small experiment right here. So if I head into my VM right here, all right, and let me click Control or Delete, and let me log in as a user called Ross. All right, so I will log in as Ross, keying in Ross's password, and we can see that Ross has now logged in. Now Ross has forgotten his password. So in this case, what happens now is if I click Control or Delete and change a password, let me give in Ross's old password and let me give in Ross's new password. All right. So check this out. This is Ross's older password. Password at 123. All right. And this is Ross's new password. That's password at 1234. All right. And that's the confirmed password. And once I hit this, we can see that the password is not changed. All right. Now that happened because AD Self-Service Plus's password policy has kicked in, thereby banning the pattern right here. All right, now let me quickly show you something else. If I head into my VM right here and let me log in as another user, sign out, and log in as a user called Brittany. All right, so Brittany is just my domain user. All right, logged in as Brittany, and let me go ahead and change Brittany's password. So once I click change a password, we can see that the settings that we have enforced in AD Self-Service Plus are now displayed right here. All right, so these are the settings that Brittany must adhere to in order to create passwords. And check this out, if I click on restricted patterns, here we are. This is one of my most favorite features of AD Self-Service Plus because the major thing Active Directory's password policy fails to do is to communicate to the end user, right? So the user never knows what kind of a password to create. But in AD Self-Service Plus, the end user is communicated. So the end user knows what kind of a password to create. All right, now let me quickly remote into my DC right here and log in as the administrator. Right, this is another quick experiment just to show you how AD's password policy is flawed. So this is my OU, and let me go ahead and change Gabriel's password. All right, so let's reset password. I'm giving in a password called password at 123. All right, password at 123, and once I hit enter, we can see that the password has been changed. Now let me go ahead and do that again. Reset password at 123. Password at 123, and once I hit enter, we can see that the password has been changed. All right, so the point I'm trying to make here is passwords can be reused how many ever times during reset, and that is not a security risk according to Active Directory. All right, now check this out. If I hit here and if I reset password for Pete right here, and let me give him the common pattern. All right, so that's password at 123. Password at 123, and once I hit enter, we can see that it has been blocked. The reason it has been blocked is because we have enforced the password policy right here. All right, so this enforced password policy works across your change password, your Gina CP screen, and your ADUC password reset as well. All right, but now all we've done is we have found a weak user passwords and we have strengthened passwords across AD. But you might ask me this question: what about password strength across my hybrid environment? Applications like Office 365, G Suite, Zoho, right? Because passwords are still used across these applications to log in. My answer to that is a password sync. That's right. We will create a strong user password using AD Self-Service Plus, and we will sync it across cloud applications. Now you might immediately ask me this question: how is reusing passwords not a security risk? The reason I'm telling you that is because passwords, if strong and unbreakable and are reused across cloud applications, will only increase our security, right? Because if an end user is given the choice to create the passwords he or she wants, there is a very good chance that they will create weak user passwords. All right, so this is how password sync works. Let me head into AD Self-Service Plus, log in as the admin. And if I head into configuration and then password sync / single sign-on. All right, now all you have to do is simply click the drop down here, select password sync. So these are all the apps that support password sync, right? So this is one dashboard to support password sync across all applications. So all you have to do is select the application that you want, in this case Office 365. Once you click edit, all you have to do is give it the name of the domain and the password and simply select the policies that you wish. Now if you can recollect, policies apply on OUs and on groups alone. All right, and once I click update, then the password sync is set up. It's that simple. Let me show this to you. If I sign out, let me sign in as a user called Abhi. All right, I will sign in as a user called Abhi, keying in Abhi's password right here. And check this out. Abhi can now reset passwords across AD and across any cloud application that is configured in AD Self-Service Plus. All right, and the best part is the policy that we have enforced takes play right here. All right, so that's one strong password across applications. Hence, we are checking the box of all-round security for our end users. And how simple is it? Everything can be managed from just one central dashboard. And password sync, of course, supports your native password change and password reset as well. So that's a single identity, single password policy across multiple applications and systems. All right. But then again, password attacks can come in more than one form. Using a standard username password combination is good. Having strong passwords is the first line of defense. But then again, we need another layer of protection to ensure complete security. A good example of this is the DC sync attack, where the replication permission of a user are exploited to get the hashes of any account in Active Directory, even an administrator's account. All right, so in order to overcome this, we need two-factor authentication. So that's stronger passwords plus two-factor authentication for complete and all-round security. All right, let me quickly go ahead and set up two-factor authentication with AD Self-Service Plus. So if I head into my browser here, I'm logged in as the admin, right? All I have to do is head into multi-factor authentication, authenticator settings, and over here, we can set up two-factor authentication. It's pretty simple. Just check the box, select the method that you wish, and set it up. All right, but the important thing to remember here is you need the HTTPS protocol because we want this process to be secure. Right? Two-factor authentication works for remote, for local, across Mac and across Windows operating systems. Let me quickly show you how this works. So this is a two-factor authentication that I had set up on my system. So once I hit play, here, user enters his password, right? And then the AD Self-Service Plus portal opens up where the user has to undergo a secondary mode of validation. In this case, an email with the verification code. And once the user enters the valid verification code, he or she is instantly logged into AD Self-Service Plus. All right, so that's one strong password and another mode of authentication before logging on to Active Directory. So a quick summary of what we saw today. So I started off by saying that Active Directory's password policy is weak. And I proved my point by performing a brute force attack on the administrator's account. We then saw how to protect the admin account and we started employing a step-by-step approach. The first approach being noticing which of our users have weak passwords. And then we strengthened the passwords using stronger password policies. Hence, passwords across AD are now strong, right? Since a hybrid infrastructure has an array of cloud-hosted applications that still use passwords as their prime mode of logon, we synced the password. We performed a password sync to securely sync the strong passwords across the cloud hosted applications, across all modes of login, on-prem and cloud. All right. And finally, to ensure and to enhance our security, we set up an extra layer of protection with two-factor authentication in AD Self-Service Plus. But the problem still exists. The reason I say this is because although we have secured user logons with a strong password, the end user's experience is not smooth, right? So users still need to put in the password to log on to any cloud application. And you might ask me this question. We have employed two-factor authentication at AD Logon. Now we have stronger passwords and two-factor authentication at AD Logon, but what happens to the cloud logons? Because cloud logons still use the standard username password combination, right? And entering passwords manually across logins can open doors to a variety of security threats. A simple one can be an attacker looking over the shoulder of a user typing his or her password, or a user hastily shares his or her password to another user or colleague, hence compromising access to multiple cloud applications. Now, in order to improve security and to enhance the user's experience in an environment where there are cloud applications as well, in a hybrid AD environment, we need stronger policies plus two-factor authentication plus single sign-on. All right. So the point I'm trying to get forth here is a user logs on with a strong password, undergoes another mode of authentication with two-factor authentication, and with single sign-on, this is the logon procedure ends here, right? So the user only has to log on once and that's it. He or she would have seamless access to all cloud hosted applications. Let me quickly show you how this is done. If I head into my VM right here, and I am logged in as a user called Brad. All right, so let me open up my browser, and if I click the URL of where AD Self-Service Plus is hosted, if you noticed, you can see that the user is automatically logged into AD Self-Service Plus. The reason this happened is because the user has already undergone two-factor authentication and password authentication at the logon. All right, now all the user has to do is click on applications and simply click, and the user is logged on to the cloud hosted application almost instantly. Now you might ask me a question. What happens if the user decides to enter the URL of the application directly, right? This is very possible. In this case, let me show you Office 365 logon. So let me sign in as Brad, right? So Brad is directly accessing his cloud hosted application. And once I enter, we can see it says taking you to your organization sign-in page, where AD Self-Service Plus authenticates the user's identity, and only then will Brad be allowed to log into AD Self-Service Plus. All right, so that is the final and the complete solution. Strong policies to protect users, not just across native, but across hybrid AD as well. Two-factor authentication for an added layer of security. And this again applies across all modes of logons, AD logon and cloud logon. And finally, single sign-on to reduce the number of times a user logs on, but at the same time to enhance the end user's experience and streamline security. All right, so thank you so much for listening. My name is Abhilash. You could always reach out to me at abhi@manageengine.com, and I would be more than happy to help you out. Now, I would be running a quick poll in order to, that's for an internal team. So let me quickly run the poll. Now you will see two questions flash on your screen. It would be great if you could just punch in the answers to those questions so I can take it forward from there. So this is the poll. Now I would be launching the first poll and you would see it flash across your screen. And here you go. So the first poll is now open. I would let this be for about 10 to 15 seconds so you can take your time and answer the question. All right, now I would be pushing out the next poll right here. I will close the first poll right now. And Let me push out the next poll, and this would be the last poll that you would need to reply to. All right, thank you so much for your responses. Now I would be here for the next 10 to 15 minutes. So if you've got any questions, please keep them coming via chat. And if I've missed answering any of your questions, I would be answering them to you via email. But now I'm here for the next 10 to 15 minutes. So please punch in if you have any questions so I can immediately take them via chat. All right.